Welcome to Not Milk Never Milk. Subscribe if you're lactose intolerant.
You begin by creating the camera game object and linking it to the scene target. This ensures the camera has a known reference. Once added, change clear flags and choose perspective or orthographic depending on your project. Next, set the field of view or size. These values control framing. Then immediately create a camera controller C#script, expose speed, smoothing, and pivot fields, and assign the target. This starts the automated behavior you will refine in the next step. Now implement the follow and rotation logic in late update so the camera updates after physics. This reduces jitter. Use Vector 3. Smooth damp or lerp for smooth positional tracking, and quaternion. Slurp for rotation so the camera turns naturally. Add angle clamps to prevent extreme pitch or yaw. To avoid scene clipping, cast a short ray from the target to the camera and shorten the distance when obstacles appear. Or use Cinemachine for built-in damping and collision handling. Finish by exposing tuning parameters, FOV, damping, follow distance, and input sensitivity so you can iterate quickly. Implement input mapping for rotation mouse or gamepad and scroll for zoom. Make sure to multiply by delta time when needed. Test in multiple scenes and profile performance. If you encounter jitter or clipping, check that you use late update, validate axis mappings, and use a raycast from the target to the camera to correct distance. That single raycast check often resolves most visible camera issues.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.